Alright, I'm back, and now we're going to start talking about 10% battery, nice. Now we're going to start talking about graphing rationals. Alright, so we got f of x over h of x. Now I took the liberty to write this in a whole bunch of different ways. Let's get, I don't know why I just did that, it doesn't really help that much. Okay, so as you can see, we've got the fifth degree polynomial here in red over the second degree polynomial, the parabola, and this is what it looks like, okay? And also in factored form, it's the exact same thing. You guys can see how the graph hasn't changed at all. I just have it in factored form. Now the one thing to see is I actually have it in another form as well. See, this blue is the exact same as the red and the green and the black. They're all the exact same graph. What is this new form? What is this 3x cubed minus 6x squared plus 24x minus 102 with this rational to the right? Well, what I did is I actually did the division. I took my 15x to the 5 minus 60x cubed minus 30x squared plus 45x plus 30, and I actually divided it by 5x squared plus 10x minus 40. So you see, this is my answer. So we have our dividend divided by the divisor, and this is my quotient. But I did have a remainder of 2025x minus 4050. So if you look in here, this is my conclusion. This graph that we were graphing here is also the same as this right here. But the cool thing about this is when numbers are small, well, this is going to be a pretty large number, so it's going to make a huge difference, and this is not going to be near this cubic at all. So this is a cubic, and I'm going to show you that cubic right now. So I actually graphed that cubic right here. Let's see, we got q of x. We should give me a better window here. Let's try negative 2500 and 1500. Okay, so if you look here, the blue is my p of x, and it's also my f of x over h of x. And so those are all the same graph. Okay, well here, 11, 12, 13, and 14, that's all different forms of the same graph. Okay, so this 3x cubed minus 6x squared plus 24x minus 102. Well, that's this blue thing here, but this extra amount, this remainder here, you can see makes a huge difference when x is small. Like my graph here in this area is not at all the same as my graph of q of x here. So my q of x is just your normal cubic that we know how to graph. Okay, but as you get farther and farther, as you get closer and closer to x is infinity, so like it really comes close, like it actually approaches that thing. So it might as well just be that cubic way off to the right. And the same with the left. It kind of comes in, okay, and it might as well just be that cubic. But in here, no way. We have these asymptotes, we have these different zeros. Let's see what happens in close here when y is really small. Right? See how all these things are happening in here, not at all near the asymptote. But as soon as you get out near that asymptote, sure enough, it gets close to that asymptote. Okay? So the way you can find out every single time what happens, like where it approaches your like what your asymptote is to actually do your division. When you actually do your division, the asymptote will always be this number up here. Okay? And the remainder won't make any difference at all when you're way off to the right or to the left. But in the middle, it makes a huge difference. So in the middle, it's not at all equal to the asymptote. It's just when it gets off to the side that it equals the asymptote. All right, I'm going to come in with another one and another lesson, but that's all for this one.